Okay, so we are doing the second part of the notes on ellipses, part 2 of 7.3. With 3 examples in this part of the notes. So first we're going to graph the ellipse, and here's the equation, and notice that that's not in standard form of an ellipse. So let's remember that our goal is to have it look like this. X minus h squared all over r sub x squared plus y minus k squared all over r sub y squared equals 1. So the first thing I want you to notice is that's a perfect square and that's a perfect square. So it would probably be a good idea to write my x's as a perfect square and my y's as a perfect square. So we're going to do completing the square, which we've recently done on circles, so this should be really familiar. The first thing would be to rearrange the terms so the x's are together and the y's are together. And at the same time, I'm going to move my constant term to the other side of the equation. So 4x squared minus 40x, those are my x terms. I'm going to leave space because we're completing the square. And then my y terms are 9y squared plus 36y. And again, leaving space because I'm completing the square. And I'm going to also subtract 100 to move my constant term to the other side. I am moving it to the right. I'm sure that will be fine. The next step, now when we were doing this with circles, we did not have a coefficient in front of the x squared, but now we do. So think back to when we were doing this on simple quadratics. If there was a leading coefficient, we had to factor it out. So I'm going to factor out the 4. This was 40. Okay, copied that wrong. So factor out the 4, leave space because we're going to be completing the square. Factor out the 9. And leave space because we're going to complete the square. I didn't change the right-hand side. All right, the next step is you're going to add, can you see that? Let's see. We're going to add b over 2 squared into each group. So it will be a different b over 2 squared for the x's and for the y's. So negative 10 over 2 is negative 5 squared is 25. So I'm going to add 25. And anytime I add something to one side, I have to add the same thing to the other side. So I actually added 4 times 25, which is 100. So I'm going to add 100 to the right. That's really important. So I'll write in parentheses, that was 4 times 25. All right, now what do I add here? So b over 2, so b is 4. So 4 over 2 is 2, 2 squared is 4, so I'm going to add 4. So I changed this side of the equation by adding 9 times 4. So I have to add 9 times 4 to the right, so I have to add 36. And I got that by doing the 9 times 4, so I'll remind myself of that. All righty. And now we're going to write these as perfect squares. So it's always x plus b over 2. So the perfect square part, that's my square. B over 2, negative 10 over 2 is negative 5. Keep the coefficient. Rewrite this as a perfect square. So it would be y plus b over 2. B over 2 is 2, so y plus 2. And now I'll add my terms on the right. Negative 100 plus 100 is 0, plus 36 is 36. This is looking pretty good. I'm really close. I have my perfect squares, but what I don't have is denominators. And on the right-hand side, I don't have a 1, I have a 36. So let's try dividing the entire equation by 36. So every term, and see what happens. I did that because I want a 1 on the right, so dividing by 36 gets me what I need on the right. And now if I reduce the fractions, 4 over 36 reduces to 1 over 9. So I get x minus 5 squared, and the 4 over 36 reduced to a 9 in the denominator. And I'm also going to reduce the 9 over 36, which reduces to 1 over 4. So I have y plus 2 squared over 4. And that is, in fact, standard form for an ellipse. So we're in really good shape. So now we just need to gather all the information that we need in order to graph this, because the directions were actually to graph. So the new thing was completing the square, and now we're going to graph. So I'm going to do this part kind of fast. So the center of the ellipse is HK. So that'd be positive 5, negative 2. R sub x, under the x, it's the square root, so that would be 3. And r sub y, square root of this denominator under the y, so that would be 2. And I'm going to remind myself here that this is the long axis. So that reminds me that my foci are going to move along the x direction. And now I'm going to find the 4 vertices. So I can always just do this. I don't actually have to think yet which direction is longer. I can just take my center and add my r sub x to the x, because it changes the x, and leave my y coordinate of the center alone. Simplify that. So that's one of the vertices. And then do the one where I go in the other direction on the x-axis. And that gives me another vertex. All right, so that was the 2 vertices where I moved in the x direction. Now I start again at my center, but now I'm going to change my y's by adding and subtracting the r sub y. So first I'll add, so that gives me 5, 0, another vertex. And then I will also subtract my r sub y from the y, and that gives me 5, negative 4. That's my 4th vertex. Great. I have 4 vertices and a center. So next I want to work on the foci. So in order to find the foci, I need c. So c squared equals a squared minus b squared. A is the larger of the 2 radii. So that'd be 3, but it's squared, right? So it's 3 squared, or you could look back at the denominator, so the larger denominator. So 9 minus 2 squared, which is 4. So c squared is 9 minus 4, which is 5. So c is 5, which is fine, but I'm going to round it by typing it into my calculator, 2.2, because I'm going to need to be able to plot it in exactly or approximately the right place. So this is more helpful to me right now. So I'm going to move over here so I have a little bit of room. And I'm going to work on the foci. So remember, the long axis is in the x direction, so I'm changing x. So I start at my center, and I add c to the x because it's along the x direction, and I leave y alone. So that gives me 7.2, negative 2. So that's one of the foci. And then I do it again, where I take x and subtract c, leave the y alone. So that gives me 2.8, negative 2. So that's my other foci, my other focus, and I'm ready to graph. Okay, so I'm going to put my center on. I'm just going to put these points on here and draw my curve. So center, 1, 2, 3, 4, 5, negative 2. I'm labeling it center. And then my vertices are at 8, negative 2, and 2, negative 2. So that's another one. And 5, 0, that's another vertex. And 5, negative 4, that's another vertex. And now the foci, maybe I'll do those in a different color. Do those in red. So I have one at 7.2, negative 2, so that's about here. And another one at 2.8, negative 2, so that's about here. And now I'm ready to make my nice ellipse or oval shape, if you want to think of it that way. And we're done. Great. Now moving on. We're finding equations. Two more problems. So we want to find an equation where the center is given and two vertices are given. So again, we'll remind ourselves of the goal. So the goal is to put it into this form. So we've got H and K given to us by looking at the center. And hopefully from the vertices, we can find R sub X and R sub Y, because those are the only other things that we need in order to write this equation. So remember, when we were finding the vertices, we started with the center and we added R sub X to the X coordinate. So let's write the center down. So the center is 2, and I'm leaving myself space. And remember, again, in order to start with the center and get a vertex, you would add or subtract R sub X to the X, because that changes X. So if I look at the vertex where the X changes, notice this has the same X as the center, and this has a different X. So if I look at this one, this vertex, I have 7, -1. So to get that vertex from the center, in the previous examples, I would have taken 2 plus R sub X and gotten 7. Or you might have needed to subtract R sub X, so think about which one's going to work. So now we solve R sub X equals 7 minus 2, so 5. R sub X is 5. Look at that, we got R sub X. So we'll come back and use that in a minute. So now let's see if we can find R sub Y. All right, same kind of thought process. So let's start with the center. We used this one. So we used that one. So maybe this vertex is going to be helpful. So start with the center, which again was 2, -1. I'm leaving space because this vertex has a different Y and the same X. So in the past, when we were going the other direction, we would have taken the Y coordinate and added R sub Y, or subtracted, but in this case, this is larger than that, in order to get this Y coordinate of the vertex. So I can now write an equation that relates these. So -1 plus R sub Y equals that Y coordinate, which is 6. So add 1, and R sub Y equals 7. Oh, look at that, we've got everything. So now we're ready to write the equation. So our equation is X minus H, always the opposite sign, so -2 squared, over R sub X squared, so 5 squared is 25, plus Y minus K, so minus -1, so plus 1, that came from this, squared, all over R sub Y squared, so 7 squared is 49, and it always equals 1 when we're talking about an ellipse. And there it is. All right, next example. So now we want the equation of an ellipse when we have a center, a vertex, and a focus. So using the vertex, that's similar to what we did before. So let's start with that. We know what form we're looking for because we wrote it down a few times during this lesson. So we're looking for that. So we have HK from the center. And let's see if we can find R sub X or R sub Y easily. So the vertex is slightly easier to work with. So let's look at that. So start with the center, because that's the way we did it when we did it forward. And the center is 2, I'm leaving space, comma 3. And from the center, I could get the vertex. So the vertex is 7, 3. So notice the Y stayed the same and the X has changed. So to get from the center to the vertex, I would have added R sub, I changed an X in this example, so plus R sub X to get 7. So I can write an equation, 2 plus R sub X equals 7. And that tells me that r sub x equals 5. So that's really nice. So now I have hk and r sub x, but I don't have r sub y. I also don't have another vertex. I have a focus. So since that's what I have, that's what we have to work with. I'm going to go over here so I don't run out of room below. So I'm going to work with the focus. So I'm going to start with the center again, which is 2, 3, leaving space. And my other fact that I didn't use is that I know the focus is 6, 3. So the focus has the same y coordinate and the x coordinate is different. So in the past, I would start with the center and I would change either the x or the y, but the x is the one that changes by adding or subtracting c. Since 6 is bigger, I obviously added a c. So 2 plus c would give me the 6. So 2 plus c equals 6. So that tells me c equals 4. So I'm part of the way there to finding r sub y. So let's make sure we know what axis the focus is on. So notice we changed x to get the focus. So that means that the focus is on the x axis of the ellipse. That means that r sub x is larger. So in our function that a's, b's, and c's, that means this is the a, the larger, right? So if we're going to use c squared equals a squared minus b squared. So we know c now, so that's 4 squared. So a is the larger of r sub x or r sub y, so it's r sub x, which we know. So that's 5. So 5 squared. And b squared we don't know. So now we have 16 equals 25 minus b squared. 16 minus 25 equals b squared. So, oops, negative b squared. So negative 9 equals negative b squared. So 9 equals b squared. I could keep going and solve for b, but what I actually need is b squared. So I'm going to stop. And this was either r sub x or r sub y. We already have r sub x. So this means that 9 is r sub y squared. All right, we're ready to write our equation. So here we go. So x minus h, which is 2 squared, over r sub x squared. So r sub x was 5, so r sub x squared is 25, plus y minus k, so 3 squared, over r sub y squared, which is 9, equals 1. And there's our equation.